Good afternoon. My name is Roomi. I'm going to present our project, measuring website login policy at scale. So password today remain the most dominant authentication mechanism in the web. And while the process of logging in looks simple, it actually involves a multi-stage workflow where the security, privacy, and usability are directly impacted by the authentication policy and the implementation decision. Things like what is the accepted password structure and how password is transmitted and stored in the server. All these decisions has been heavily studied in the literature, and we have a clear idea of what are the best practices. However, a question remains: are the websites in practice adopting these password authentication policies, the best practices, and how are they handling password authentication in general? This has motivated our work where we want to measure the website authentication policies in practice, and to get a much clearer picture, we want to measure at scale. Since we want to measure at scale, we want to do things at automation. So we developed a web measurement technique that automatically infer websites' login policies. Now, since we are dealing with measuring login policies, some of these policies require us having accounts in these domains. So a first step is to measure, to actually create accounts before measuring the authentication policies. Now, there are tons of policies to measure. There's tons of decisions. So we focus on those that surrounds the login workflow. And this decision is because it is a recurring process done by the user that directly impacts the security of the accounts. So what we mean by a login workflow, when a user wants to log in, they visit the login page, enter their credentials, submit the login form, which transmit the password to the server, and the server has some part or some identification of the password, which is retrieved and compared with the submitted password, and a final decision happens for the login, whether it succeeds or fails, and we focus on what happens when it fails. In all these workflow, we want to see what decisions are websites taking in terms of impacting the security and the privacy, and also the usability. Specifically, we want to see if the login page is encrypted or not, and if there is a mixed content in the login page. We also want to see if during the submission of the credentials, whether users are allowed to copy and paste their credentials, as it increases their usability and also encourage the use of password managers. We also want to see if how the password is transmitted to the server, either securely or in plain text, and how password is stored on the server. Also, during password validation, when there's a comparison between the submitted password and the password in the server, is there a typo tolerance scheme implemented? This is a recent scheme where the password submitted is allowed to have a small typo in it and still get accepted. And finally, we want to see how the websites react when a login fails. Specifically, what kind of errors shown, and whether there is an implementation of rate limiting. Now, there's a lot of details in the paper on how we designed our methodology, but at a high level, while there is indeed diversity in the login workflow, there is still some commonality. So in order to design our methodology, we have manually sampled a set of domains in order to identify what is common between the login pages. And using that, we identified the common workflow and the heuristic and the features to help us in automating our progress. This is done, of course, for account creation in automation and also for the measurement of the policies. Now, for account creation, we developed a mechanism to detect the form in the HTML page of the home page. If the form, the sign-up and the login form are not found, we have a mechanism to crawl from the home page trying to find these pages. And as a last resort, we also use search engine. After finding this form, we also fill the form by detecting the fields and filling them accordingly. And when we submit the form, the login or the sign-up form, we developed a machine learning model that tells us if our attempt is successful or not. And specifically for account creation, we have a mechanism to automate the account verification by accessing the email that we used during sign-up and clicking on the verification link. So now we have an account created, and we're ready to evaluate the policies. Now, I don't have time to go through all the policies, but I'm going to showcase how we evaluated and the result of some of these policies, and the rest are in the paper. For the login page visit, we want to see if the login page is encrypted or not, so we attempt to visit the login page with HTTP and HTTPS and see if it fully loads and the login form is in it. For password transmission, we check the form action attribute in the HTML form tag. And for the password storage, we design our own and control our own email server. So we try to monitor all the emails that we receive, and we see if at any point during the account lifecycle, we receive our own registered password in email. This is an indication of a possible plain text storage. For typo tolerance, since we control the sign-up password, what we do is we try to attempt logging in using a password with a small typo in it to see if they accept the typos or not. The typos that we selected are based on prior work that found these to be the most common between users. Things like forgetting the caps lock on when you try to type your password. Okay, so we applied our measurement technique to 1 million domains, and we're able to create in automation 45K domains. We also were able to fully analyze between 18K domains to 360K. Varies, depends on the stage, as some stages only require having the login page found, and others require having test accounts. Those who require having test accounts varies in how aggressive we need to be in terms to fully measure the policy. Now let's look at some of our results, starting with the login page and the password transmission. What we noticed immediately is that HTTPS has been heavily adopted in general in all login pages of the measured websites. However, there is still a reasonable number of domains serving their login pages in HTTP. Moreover, we also found domains that while they default in HTTPS and serving their login pages, their HTTP version of the page is still accessible. What is interesting is when we looked at the data set, we found domains serving government and educational websites. So these are not just random websites. Some of them are very critical and still being served in HTTP. Looking at insecure password transmission, we found 2.2K domains transmitting their password in plain text. The majority of them were HTTP-only login pages, which shows you like a bad decision at one stage usually propagates to other stages of the policies in the login workflow. Next, we look at the plain text storage. We were able to measure 45K domains. These are the number of domains we were able to create account for, test accounts. We found 570 domains sending us our own password and email, which is an indication of a possibility of a plain text storage. We note, however, that this is a lower bound measurement, as domains can have a plain text storage but not give us an indication of it by not sending us our own password in email. Of course, we request password, we check the password at different stages upon registration, after verification, and we also attempt to request password reset, which some domains send us our own password when we request or we attempt to request forgetting the password. What is interesting is that we found a quarter of our domains from the European Union, which might violate some of their data protection laws. Finally, we look at typo tolerance. The only really documented cases prior to our measurement was Facebook, which was accepting typos of different cases. So if you have a different first case of your password, it still get accepted. We were curious to see if other domains were actually implementing typo tolerance. So we measured 20K domains, and we found, in fact, there are many domains accepting typos in their password submission. The majority of them were typos related to cases. So forgetting your case on or incorrectly casing the first letter, which usually happens in mobiles, are still accepted when you type your password. What is interesting is we found that the majority of those were fully case insensitive in terms of accepting the password. So we believe that in these cases, they simply lowercase the password before doing any form of processing to the password and saving it. We also found other type of typos, such as adding extra character at the end and still getting the password accepted. The most interesting thing is that this such deployment of typo tolerance is not just to lower ranking websites, but actually we find popular domains implementing them. In this case, Pinterest, the top 50 domains, was accepting password of typo 1 and typo 5, which is incorrect casing and adding extra character at the end. There are many other measurements that we did I couldn't present in this presentation for the sake of time, and many interesting cases. If you're interested, please have a look at our paper. So we did this large measurement, and we had analyzed a large number of data. So what are the high-level lessons that we learned from our study? Well, first, this study is an example of the importance of large-scale study. In our case, we were able to uncover insecure behaviors in terms of authentication in a large scale. We were also able to uncover unique implementation of policies that we didn't know before. We also seen the influence of popular web framework. In our case, for some of our results, the default behavior of WordPress resulted in contributing towards bad policy implementation for authentication. We also see a reasonable number of domains not implementing HTTPS, which should encourage us as a community towards doing effort possibly to increase the adoption of HTTPS, especially that we found critical domains not adopting HTTPS in our data set. And finally, how can we derive a better adherence to best practices for authentication? Things like, can we study the individuals behind the decision of implementing specific policies, and what are the obstacles towards not adopting best practices? And also, how can we utilize regulation as a mechanism to derive better adoption of best practices? I hope this lesson and these lessons help us towards better adoption of authentication and across the web and also in scale. Thank you very much.